Hi, these are your notes that will go on page 21 of your notebook. So we are ordering numbers on a number line. Sounds easy, however, not all numbers look like our normal whole numbers that we've been numbering since we were kindergarten. So first, let's start with our different kinds of numbers. We have integers, which are all the whole numbers and their opposites. We have rational numbers. These are the numbers that can be written as a fraction. So yeah, some of them look like fractions, some of them don't look like fractions, but anything that you can make look like a fraction is a rational number. For example, we could make this one into a 7. 7 over 1 would make it rational, or make it a fraction, therefore it's rational. A 0.12, we can change it to 12 hundredths, 12 over 100, and then simplify it, and that would make it a rational number because it can be written as a fraction. The whole numbers are 0 and all of the counting numbers or the natural numbers. So 0, 1, 2, 3, 4, 5, 6, 7. You will not see a negative number. If it's a negative whole number, we call it an integer. And irrational numbers cannot be written as a fraction. And if it's in decimal form, it's going to go on forever and never repeat, such as square root of 3, pi, which was 3.14159265358979323. I could go on, but you get the picture. It doesn't repeat and it doesn't stop. 0.12345678910111213. That's never going to repeat. So even though there's a pattern, it doesn't repeat, won't stop. Therefore, it's irrational. Negative square root of 14. We don't know what the square root of 14 is. So even making it negative would still make it an irrational number. So now let's put some numbers on the number line. So if we have a number line, 1 to 10, underneath you're going to see the perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared, 9 squared, 10 squared. So then when you take the square root of, say, 64, we know that the answer would be 8. So when we look at these specific numbers up here, the square root of 8 is going to fall between the square root of 4 and the square root of 9. Square root of 8 is closer to the square root of 9, so you know it's going to be on this side of the 2.5 point. So I drew an arrow to there. Square root of 2 is going to fall between the square root of 1 and the square root of 4. Closer to the 1, so that's why I drew it on this side of the 1.5 sign. 34, square root of 34, we know would fall between the square root of 25, which is 5, the square root of 36, which is 6, so closer to the 36. So we know that the square root of 34 is going to be more than 5.5, but less than 6. Square root of 90 falls between the square root of 81 and the square root of 100. That one's going to be closer to the middle because it's only 9 spots away from this one and 10 away from this one. So it's going to be pretty close to 9.5. Square root of 52 will fall between the square root of 49 and square root of 64. So since the square root of 49 is 7, square root of 64 is 8, it's going to fall in the middle of those two. Actually, probably a little closer to the 7 than the 8, so I think my arrow is off just a little bit. So what I would like for you to do is type these in your calculator, square root of 8. When you do that, you are going to get, I'll do the first one with you and make sure you're doing it correctly. When you take the square root of 8, you get 2.82842, blah, 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 blah. So again, it was 2.82, and if you look here, we said the square root of 8 would be more than 2.5 because of where it fell here. So 2.82 is the decimal of square root of 8. All of these are considered irrational because they don't terminate and the decimals won't repeat when you type them in your calculator. These down here would all be rational because they are the perfect squares, and so you know what they are when you take the square root. Okay, and then down here, I want you to use your own words to get your green stamp. So how do you order irrational numbers? Or, so if you want to use words, you can, or if you'd rather create your own example, like the one in the video, or like the one I just did, You have to do that to get the green stamp on this page. Thanks for listening.